Okay, the masked professor is on the air once more. Today we'll be covering production planning and control, and we will go through problems on this in the next class. So blow it up real big. Oh yeah, it looks exciting. All right, so we're going to go through aggregate production planning and the master production schedule, material requirements planning, capacity planning, shop floor control, inventory control, manufacturing resource planning, or MRP2, and enterprise resource planning, or ERP. Of course, all of this is covered in inventory control and production planning class. All right, so production planning and control, we're concerned with the logistic problems in manufacturing, managing the details of what, when, and how many products to produce, obtaining the raw materials, parts, and resources to produce them. Production planning control solves these logistics problems by managing the information. Production planning control is the integrator in computer integrated manufacturing. Okay, the integrator. I think that's going to be Arnold Schwarzenegger's next movie. When we talk about production planning, we're concerned with deciding which products to make, how many of each to make, and when they should be completed. Scheduling the delivery and/or production of the parts and products, and planning the manpower and equipment resources needed to accomplish the production plan. So the things we do inside production planning, one is aggregate production planning. Planning the production output levels for all our major product lines. This has to be coordinated with production design, production, marketing, and sales. Master production planning is the specific schedule, the master production schedule, of the quantities of individual models in each major production line. Material requirements planning, or MRP, is the detailed schedule of raw materials and parts production for models in the master schedule. And capacity planning is planning the labor and equipment resources to achieve the master schedule. So, for production control, we're concerned with determining whether the necessary resources to implement the production plan have been provided. If not, we are going to attempt to take corrective action to address the deficiencies. Major topics in production control are shop floor control, inventory control, manufacturing resource planning, and enterprise resource planning. Our activities in our production planning and control system All right, well, we've broken it down into 4 levels here. There's operations where we are actually producing the parts, products, etc. Production control, the detailed planning, and the aggregate planning. So, boy, where to even start? So sales and marketing are feeding back and forth into product design. Sales and marketing presumably are telling us, hey, we need 50 Model A's, we need 25 Model B's, etc., etc. That all goes into the aggregate production planning, but that has to be drilled down to the master production schedule. Our sales orders and our sales forecasts are coming into the master production schedule. That goes back and forth with capacity planning. Do we have the capacity to make what is being ordered or forecast? Of course, we have inventory records. So the master production schedule comes down to the material requirements planning. That again goes back and forth with capacity planning and is informed by the engineering and manufacturing database. That comes down to our purchasing department to purchase raw materials, parts, etc. that we need, and to the shop floor control, which is going to have to keep an eye on and make sure everything is happening. At the operational level, our suppliers are giving us raw materials, parts, etc. That all goes into our factory, and the output goes to our customer base. All right, so our aggregate production planning means we're planning the production outputs for major product lines. This is a very high-level corporate planning activity, and it has to be coordinated with the plans of the sales and marketing departments. So it includes the products that are currently in production, must consider our current and future inventory levels of our products, and we also have to plan for the new products that we're currently developing. So our marketing plans for our current and new products must be reconciled against the total capacity resources of the company. So here is our aggregate production plan, where we say, all right, we have 3 model lines, the M model, N model, and P model, and by weeks, week 1, week 2, week 3, week 4, we say how many of those model lines are going to be made. So this just gives us the output, production output for our major product lines. It doesn't break it down to, all right, our M1A is going to produce so many, our M2B is going to produce so many, etc. The master production schedule, however, does break down to that. So it's our specific schedule of individual products and models that is derived from the aggregate production plan. So, in toto, it is a list of the products to be manufactured, when they should be completed and delivered, and in what quantities. So, the master production schedule will include 3 categories of items. One is firm customer orders. The second is forecasted demand for products. And the third is for spare parts. So our aggregate production plan, this is a repeat of the chart that we saw before, but then it is breaking down the master production schedule. We have the, instead of just saying the M model line, we have the model M3s and we have the model M4s. And it gives the number that is planned to produce for each of those. Then we have the model N8. Apparently that's the only, the only one in the N model line. And then we have the models P1 and P2, and that's broken down then over here. Not doing mixed model production. Very poor planning. Material requirements planning, or MRP, this is a computational method that converts the master production schedule for end products into a detailed schedule for the raw materials and components used in the end products. So this is something that we use for our dependent demand items, not independent demand items. So our independent demand items are the final products and the spare parts. Our dependent demand items are the component parts used in the final products. So in other words, if we're going to make tables, as an example, then we would have, for every table, we would have 1 tabletop, 4 legs, so many runners for the sides, and so on. So our structure of an MRP system, we have our master production schedule, that's feeding into our material requirements planning. Our inventory records are going to inform us because we may have parts or produced components that will go into what we need to produce the products we're looking at. We're also looking at our bill of materials and any other design and manufacturing data that's necessary to know for building these. So our material requirements planning then gives us our planned order releases for purchasing of raw materials, parts, etc., and manufacturing and other output reports, so that we know what do we do with these raw materials, parts, etc. when they get here. So we have inputs to the MRP system, our master production schedule. We express that in terms of time buckets. That can be weekly time buckets or daily time buckets. It could even be hourly, but I've never seen one broken down that far. Second is our bill of materials file. That gives us our product structure and the list of component parts that we need for each product. The inventory record file, or item master file, is going to have the item master file, that's the part number, order quantities, and lead times. Our inventory status, that is a time-phased record of our inventory status. And subsidiary data that we may need, purchase orders or engineering changes to the product. So a typical product structure looks something like this. The product itself is right here, in this case P1. We have subassemblies S1 and S2. Again, this is typical. We could have S1, S2, S3, S4, however many. Those subassemblies are made up of components, in this case C1, C2, and C3, and S2 is made up of C4, C5, C6. And then our material, which goes into our components that make up our subassemblies that make the product. And the music goes round and round, O-I-O, E-O, and it comes out here. All right, so we have an inventory record file, and in this case, our item is the raw material to make M4. Right? So right now, we have on hand, we have 50 units, right? We're not told what this raw material is. Is it steel? Is it plastic? Is it board feet of wood? Exactly what? We're scheduled to receive some in the third time period. So our on hand, there's no demand in time 1, so that goes forward. There's no demand in time 2, that goes forward. We have a receipt in time 3, and that's added on to our 50 on hand. Some factors that can complicate our material requirements planning. Our net requirements is going to equal our gross requirements less the on-hand inventory and less quantities on order. Okay, well, that's exciting. We will go through at least one MRP type problem in the next class. Okay, so if you're not 100% getting this, don't worry about it. Common use items, what are the raw materials and components used on more than one product, right? So we may have, if we are a furniture manufacturer, we may have a large amount of lumber, screws, bolts, other things that are needed to assemble the furniture that is just on hand, ready to be used. Lead times are our scheduled delivery of end products that must be translated into time-phased requirements of the components and materials by factoring in lead times. Okay, so lead times are the amount of time it takes to get something. So we can have ordering lead times. That's the time between when we send a purchase requisition and we receive our materials from the vendor. The manufacturing lead time is the time between when we release the order onto the floor and when it is completed. All right, so what are our MRP outputs? Well, for our planned order releases, we have purchase orders. There we're buying our raw materials and our parts. And we have work orders to make parts and products. Right? Again, we may make a lot of stuff, but there's always going to be a need for the raw materials to make our stuff and a lot of commercial off-the-shelf type of stuff that we may need to make our products, that it's just too much to have to worry about in-house. You know, bolts, nuts, screws, small components, springs, all kinds of things that we just say, you know what, better to have somebody else make that and we'll buy it. So we need a report of planned order releases in future periods. We need rescheduling notices because MRP is a system where we can do inputs and discover, well, to make this on time for our order, we should have started 3 weeks ago. Cancellation notices, if an order has been placed, but then they say, you know what, we reconsider. Inventory status reports, performance reports, exception reports, and inventory forecasts. So what are the benefits of having a material requirements planning as the users see it? Well, one is a reduction in inventory. Of course, we know we always want to reduce inventory because inventory represents money. A quicker response to changes in demand. We can easily explode new orders through the system. Reduce setup and changeover costs. Better machine utilization, damn it. Improve capacity to respond to changes in the master production schedule, and for that matter, aid in developing the master schedule. All right, so for some though, an MRP system does not work. Why would that be? Well, one reason might be that the application wasn't appropriate to the situation. The product structure may not fit the data requirements of the MRP. Our MRP computations could be based on inaccurate data. This is something that I've seen a lot of times in industry, is the inventory is calculated wrong, but we're still making decisions based on the wrong inventory. And the third is that our master production schedule was not linked to our capacity planning. So our MRP in that case generates an unrealistic schedule of work orders that overloads the factory. Well, that brings us to capacity planning. In capacity planning, we determine what labor and equipment resources are required to meet the current master schedule as well as long-term future production needs of the firm. Okay, well, that's exciting. We can also identify the limitations of the available production resources so that an unrealistic master schedule is not planned. Okay, so capacity planning has got to go with working on our material requirements planning and our master schedule. So we have 3 stages of capacity planning. First is the resource requirements planning. We are going to evaluate there whether the aggregate production plan is feasible. Our second stage is our rough cut capacity planning, so that we assess the feasibility of our master production schedule. And then we have our capacity requirements planning. That is a detailed capacity calculation for individual departments and work cells. All right, so all 3 of these types of planning have to go into our capacity planning. All right, so our resource requirements planning goes into the aggregate production planning. Our rough cut capacity planning goes into our master production schedule. And our capacity resource planning goes into the material requirements planning. All right, so all 3 of these, though, are capacity planning that needs to be done at each of these levels to make sure that we're talking realistically and we're not just talking blue sky. Well, of course, we are going to find out that our capacity does not match what we want to do. And there are some things that we can do both short and long term to make those a better match. Short-term capacity adjustments can be with employment levels. Are we going to hire more people because we don't have enough? Or is business way down and we need to think about layoffs? Temporary workers can be a very short-term answer to the problem. In fact, some companies employ what they call permanent temporaries. People who don't necessarily want a full-time job, but for whatever reason, they have kids at home, they're working on their college degree, whatever the reason is, they don't want full-time work right now. But they do want some work to make some money on the side. So this is a very popular thing in certain circles. what is the number of work shifts per period? Are we going on one shift a day? Are we doing 2 shifts a day? Can we add a Saturday shift temporarily to catch up with our schedule? What are the labor hours that we're having on each shift, right? If we have people working an ordinary 8-hour day, can we temporarily have them work 9 or 10 hours a day so that we catch up? Or, on the other hand, if business is way down, can we say, look, we need to reduce everyone's hours on a temporary basis until we have an uptick in business. We can have inventory stockpiling so that we can smooth our production and maintain a steady employment. But of course, this implies money tied up in inventory, and money is tied up in having storage space for the inventory. Maybe we can employ the old strategy of order backlogs. I'm sorry, we can't get you your order in 2 weeks like we wanted to, but if you can wait 3 weeks, we'll have it all done. Or subcontracting. Having people that we know we can trust to put together part of our orders, and maybe at a time when we're not busy and they are, they'll give us part of their work. Long-term capacity adjustments can be, well, add capacity, buy some new equipment, invest in that. If we really need a lot more capacity, build a new plant. Possibly purchase an existing plant from another company. Or even buy the whole company so that we have extra capacity. And if things are going the other way, we may have to close a plant or temporarily shut it down. All right, so that brings us to shop floor control. Our shop floor control, we're concerned with releasing our production orders to the factory. Then we monitor and control the progress of orders through the plant. So we are acquiring current information on the status of the orders, right? We want to keep close track, not just say, all right, here's a bunch of stuff, guys, get that order done. Often this is paired with a manufacturing execution system, or MES. So that's a computer software supporting shop floor control. Typically, this is going to include a capability to respond to online inquiries about the status of orders that are in the shop. Other manufacturing execution system functions may include generation of process instructions, real-time inventory control, and labor tracking. All right, so we're looking at where does our shop floor control fit into the production planning and control. So we have our master production schedule, It's going into our material requirements planning. Our engineering and manufacturing database is helping inform that, and also when we should release orders. The master production schedule also goes into priority control. If we know an order can be delayed, then we can put another order in front of it that is more urgent. All right, all of that goes into our order release. When are we going to release the orders? We don't just push everything out on the shop floor and then say, all right, boys, let us know when you're done. It also informs our order scheduling. Again, priority control. Is one order more important than another? Is an order late and we need to give it the fast lane? Our order progress, keeping track of how well things are going. And all of this goes into the factory as our shop packets to get our work done, our dispatch list, what is the order in which it should get done, and our factory data collection system, right? We want to keep track of what's happening so that we know where orders are, what orders have been fulfilled, and ideally, what problems are we having, where is our capacity tight, etc. Right? And then all of that goes into taking our raw materials and components, running them through the work centers until we have our finished goods. So our three phases of shop floor control are the order release, the order scheduling, and the order progress. Our order release gives us the documentation so that we process a production order through the factory. So in a shop packet, you'll have a route sheet, that's the process plan, what order of operations on what machines, etc. The material requisitions, so we draw the raw materials from the inventory. Job cards, where we report the direct labor hours that are used on the order and track the progress of the order. Move tickets authorize the transportation of parts between work centers. Sounds like a Kanban to me. And the parts list, if there's an assembly involved. Our order scheduling is going to assign our production orders to the work centers in the plant. Again, remember that not everything goes to every work center. So it is going to execute the dispatching function in our production planning and control. So that gets rid of two problems in our production control. First, the machine loading. We're going to allocate the orders to the work centers. That feeds into our shop loading, which is loading all the machines in the plants. Ideally, all of our machines and work centers are working at almost 100% capacity. Second, our job sequencing. Determining the sequence in which our orders will be processed through each work center. Then our priority control, again, that sets our appropriate priority level for our production orders. So we may use some different dispatching rules in priority control. First come, first serve, usually known as FIFO for first in, first out. The earliest due date is another very popular rule of priority control. Shortest processing time, the least slack time. So our slack time is the time remaining until the due date minus the processing time remaining, damn it. And critical ratio, the ratio of time remaining until the due date divided by the processing time remaining. All right, so obviously the smaller the critical ratio, the more we want that job to go to the front. Our order progress, we're going to monitor the status of the orders in the plant, the work in process, and the other parameters we use that indicate our production progress and performance. Our purpose is to provide information that's useful to manage the factory based on the data collected from the factory. The reports that are generated by the order progress module are work order status reports that tell us, are the orders on schedule, are they behind, are they ahead? Our progress reports, the number of orders that have been completed versus the number that should have been completed. Exception reports for overdue jobs or other exceptional circumstances. All right, so a factory data collection system, that's our various paper documents, terminals, and automated devices in the plant that collect data on the shop floor operations. So this includes methods by which we're compiling and processing the data. The functions of the factory data collection system are to supply status and performance data to the shop control, a floor control system, and to provide current information to the production foreman, plant management, and production control personnel. All right, so the types of data that we're looking at are things like the piece counts completed at each work center, the parts that are scrapped or need rework, the operations completed, the direct labor time on every order, the machine downtime, and time clocks for the employees. Now, often this is done manually. So manual or clerical data input techniques, the production workers read and fill out paper forms indicating order progress data. So examples might be the job traveler, where workers record their time spent, the piece counts, the rejects, all of that onto a log sheet that travels with the shop packet. It also might be by an employee timesheet, where the workers fill out a daily timesheet indicating orders worked on, pieces completed. It could be operation tear sheets. These are pre-printed sheets that we separate from the shop packet, filled out, and then we turn those in. So, for a semi-automated data collection system, we might use hardware and technology like specialized keypads or conventional keyboards, optical barcode readers, any other automatic identifications and control system. The configurations might be having one centralized terminal, satellite terminals, or workstation terminals. An automated data collection system, the equipment on the shop floor is digitally connected to the Industrial Internet of Things, or IIoT. That way, our information on our status of production can be seen by management in real time. This is enabled by a communication standard called MT Connect. So MT Connect is an open source, royalty-free protocol based on internet standards that allows the retrieval of data from factory equipment for shop floor control. Okay, good enough. Inventory control, we are worried about two conflicting objectives and how to make a compromise between them. The first is minimizing the cost of holding inventory. If we keep inventory, that costs money. So we want to keep inventory to a minimum. However, our second point of tension is maximizing our customer service. So that implies that we keep large enough stocks on hand so that if a customer shows up and wants a part, a product, they can immediately receive that. So what are the costs of holding inventory? Well, there is an investment cost. The cost of the money that is tied up in the inventory until the customer pays for the finished product. There are storage costs. The cost of the space to store the inventory. That neglects the cost of having people come by and count it to make sure that we have the inventory we're supposed to have, and having people guard it. The cost of possible obsolescence or spoilage. So the value of that inventory may go down if it's dropped and broken, or if it is damaged in any way. So when we put all these costs together, we think of them as carrying costs or holding costs. That brings us to the idea of order point inventory systems. So we have two problems that about managing inventory of these independent demand items that have to be solved. One is, how many units should be ordered? Usually we solve this by using any one of several economic order quantity formulas, right? And there are different economic order quantity formulas. There's the basic one, there's the one for if we allow back orders, there's the one for if we allow late deliveries. Believe me, there's no end of formulas here. And the second question is, when should that order be placed? So we solve that using a reorder point method. All right, so our inventory model for a make-to-stock type factory or production situation. We assume that we can graph our inventory level over time. Okay, so our y-axis is our inventory level and our x-axis is time. So we start with a certain amount of inventory and it is declining because we are using it, and then we receive an order and our level goes back up, and again it's declining steadily over time. So our order quantity is this amount here. The demand rate is exemplified by the slope of the line here. So this is our maximum inventory level. This is our average inventory level. And down here, this is no inventory at all. All right, so when do we use the economic order quantity formula? All right, so when we use it, first of all, we want the demand rate for the item to be pretty close to constant. Doesn't necessarily have to be exactly constant, but that's the useful way to think of it. And our rate of production is greater than our demand rate. The economic order quantity model, I should say, we also use in between units in our own production facilities at times. All right, so our total inventory cost equation, the total annual cost of inventory, we have two terms: the cost of holding the inventory and the cost of reordering or setup. So our equation for that total inventory cost, or TIC, is that the TIC, total inventory cost, equals the cost of holding times the quantity divided by 2 plus the cost of setup times the demand, the annual demand of inventory divided by the order quantity. All right, so our CH is our holding cost, Q is our order quantity, CSU is setup cost or order cost, and our DA is the annual demand for the item.
Okay.
Here is our economic order quantity formula. Using the derivative of the total inventory cost with respect to Q and setting the derivative equal to 0, Q equals our economic order quantity equals the square root of 2 times our annual demand times our cost of setup divided by the cost of holding. So reorder point systems, our actual demand rate is usually not constant, although usually we think of it as being that way to simplify our mathematics. However, in this case, we use what's called a reorder point. That means that the time to reorder occurs when the actual inventory level falls below a point that we call the reorder point.
So the last technique in covering this problem.
All right, so here we see how a reorder point system works. When our inventory reaches the reorder point, the next order for quantity Q is placed. All right, so our quantity is coming down. It hits the reorder point line. We place an order. It's still coming down, and then we get an order. And again, it's coming down. Again, it's not a straight line. It hits the reorder point, and after a certain period of time, we get a new quantity. Right? From the time it hits the reorder point and we reorder till when it arrives is our reorder lead time. All right, well, we talked about manufacturing requirements planning. Now we're going to talk about manufacturing resource planning, which is known as MRP2. This is a computer-based system for planning, scheduling, and controlling our materials, resources, and our supporting activities that we need to meet the master production schedule. So we have 3 main modules in MRP2. One is the material requirements planning. So that's planning for materials, parts, and assemblies based on the master production schedule. 2 is capacity planning. That interacts with the MRP module so that we ensure our schedule is feasible. And then 3 is our shop floor control, where we have feedback control using our factory data collection system to implement the order release, the order scheduling, and the order progress. So really what the MRP2 system does is it wraps up some of the functions that we've been talking about into one bundle. All right, so we have our master production schedule, and our manufacturing resource planning, or MRP2, takes over the material requirements planning, the capacity requirements planning, and the shop floor control. Our enterprise resource planning, or ERP, this is a computer software system that organizes and integrates all of the data and business functions of an organization through a single central database. So those functions include sales, operations, inventory control, human resources, marketing, logistics, accounting, purchasing, distribution, and finance. So the ERP runs as a client-server system. Users access the system through their PCs. So an ERP operates on a company-wide basis, not just on one plant's. Now, one thing I should say is, if we don't already know how our system functions, it's going to be very hard to change to an enterprise resource planning system. All right, so here we have all the possible software modules in the ERP system. Engineering data management, human resources management, manufacturing resource planning, financial management, supply chain management, customer relationship management, and project management. Oh dear. All right, so when we talk about the engineering data management, that's going to be product research and development, product design, computer-aided design, bills of materials, product data management, product lifecycle management. Our manufacturing resource management is going to be master production scheduling, material requirements planning, capacity planning, shop floor control, process planning, inventory control, product costing, and quality control. Our supply chain management is going to be supply chain planning, vendor relationship management, supplier scheduling, purchasing, and inventory management. Project management is going to include project planning, project costing, work breakdown structure, project scheduling, and project control. I'll bet my project management students would like to know about that. Human resources management includes payroll, benefits, training, workforce planning, recruiting, job applicant processing, job descriptions, training, employee performance appraisals, employee personal data, time and attendance, retirement and separation, and an organization chart. So very vague. Financial management includes capital budgeting, asset management, investment management, cost accounting, cost control, activity-based costing, accounts payable, accounts receivable, and cash management. And bringing it all home is customer relationship management. That includes sales, marketing, customer contact, customer service, order input and processing, pricing, product availability, delivery, shipping, invoicing, product returns, and handling of customer complaints. All right, so an advantage of ERP is that we're using a single database. So that avoids the problem of data redundancy or conflicting data in different databases. Also gets rid of the problem of time delays in entering the data and of communications issues between different databases. So everyone in the organization can access the same data according to their job responsibilities. Of course, we restrict so that not all data can be accessed by all employees. And as if I needed to remind you, this work is copyrighted, so don't go stealing it. Anyway, thank you very much. It's been an exciting time. This is November the 2nd, 2020, and the masked professor is out.